Our next type of factoring we're going to work with is called factoring by grouping. When we have four terms, quite often it's easier to factor by using a divide and conquer strategy. And it's based on this idea that the GCF doesn't have to be just one single term. It could be a binomial. Notice both halves of this problem have x plus 2 as a factor. We can treat that x plus 2 as the GCF that gets factored out front. And then what's left is the 4x and the minus 3. This is the idea that drives the four-term divide and conquer or factor by grouping method. When we factor something with four terms, we will often split the expression in half and factor the GCF out of the left and right side. When we do this, hopefully we will find a binomial GCF that they both share. So for example, if I have x squared y plus 7y minus 2x squared minus 14, we're going to divide this into the left and right sides. On the left side, we have x squared y plus 7. They both have a y in common. So if I factor out the y, we're left with x squared plus 7. On the right side, we'll always take the sign with it, negative. They both have a 2 in common. Dividing out the 2 leaves us with x squared. It's a negative 2. Negative 14 divided by negative 2 is a positive 7. Notice when we've done this, we do get that binomial GCF in common. We can factor out that x squared plus 7 to the front, and what's left is the y minus 2. Factoring by grouping is actually quite simple because it's just doing a GCF with two terms and then finding that binomial factor. So nobody's going to have to make this face when they miss the factoring problem every time. Four terms, factor by grouping. Four terms is the clue that we can use this method. Let's take a look at another example. Here we have 54x to the fourth plus 9x cubed plus 36x squared plus 6x. But before we dive right into factor by grouping, we have to remember what always must happen first on all factoring problems. The GCF. Always look for a greatest common factor first. And you'll notice all these terms are divisible by 3. And they all have an x on them. So let's take that 3x out first. 54 divided by 3 is 18. X cubed after one of the x's is pulled out. Plus 9 divided by 3 is 3x squared. Plus 36 divided by 3 is 12x. Plus 6x divided by 3 is 2. Now we're ready inside the parentheses. That 3x is just going to kind of hang out front for the rest of the problem. Inside the parentheses, we'll divide it in half. Looking at the left side, we've got this 3x hanging out. 18x cubed plus 3x squared. What do they have in common? They're both divisible by 3x squared. That's going to leave us with 6x plus 3x squared divided by 3x is 1. On the right side, keeping the sign, 12 and 2 are both divisible by 2, leaving behind 6x plus 1. And just like we were hoping, they both have that binomial GCF. Keep that 3x out front. Then there's the 6x plus 1 that they had in common. Then we have 3x squared plus 2. And now we have factored using grouping. But don't forget what we've already learned. We always have to check for that GCF first, get that out of the problem, and then factor what's left, those four terms, by grouping. Now, sometimes it doesn't work out quite as perfectly. Like, for example, in this problem, if we were to split it down the middle, on the left side, they have really nothing in common. So maybe we could factor out a 1. On the right side, again, they really have nothing in common. Maybe we could factor out a 1 again, but that's not going to help us. So what we're going to have to do in this case is back up and see if possibly changing the order of the terms might help it factor better. We need to take something from the first group and move it to the last group. And I usually just grab that second term and kick it to the end and see if that helps us. So that'll give us 35p plus 5 plus 7pq plus q. Just changing the order, hoping that that behaves better for us in our grouping. Now on the left side, we have a 5 in common. Pulling that out, we end up with 7p plus 1. And on the right side, we have a q in common. Pulling that out, we have 7p plus 1. Sure enough, just like we were hoping for, that 7p plus 1 lines up. And we're left with 5 plus q on the other factor. And now we are completely factored. So if the grouping doesn't work out quite right, always try taking that second term and kicking him or her to the end and see if that makes it behave better. But other than that, factoring by grouping is usually quite straightforward. We can even use the grouping method to solve equations using the zero product rule, like we saw with the GCFs. This time, though, we're already equal to 0, so we just need to factor. Splitting in half, there's no GCF overall. Factor out the x, leaves y minus 2. On the right side, we'll factor out the negative 3 that they have in common. Leaves y minus 2, because we're dividing by a negative. Notice we have that binomial GCF of y minus 2, like we were hoping, times x minus 3 equals 0. So we equal to 0, we factored, and now we set each factor equal to 0. Y minus 2 equals 0, and x minus 3 equals 0. Add 2 to both sides, and y equals 2. Add 3 to both sides, and x equals 3. Either y equals 2 or x equals 3, either one of those will guarantee that our equation is a true statement. And that's how we factor by grouping. Factor the left and right sides, and hopefully we'll find that binomial GCF in common on both.